when SQ3R in your lesson 4.6, you should have been introduced to, if you didn't already understand it before, slope-intercept form, and not only how to write an equation in slope-intercept form, but how to be able to pull the slope and the y-intercept from the equation when it is in slope-intercept form, and you should have learned something about graphing with slope-intercept form. Now let's talk about, first of all, what other forms do you already know for a linear function? What are the kinds we've already dealt with? Does this one sound familiar? AX plus BY equals C. What form is that? I feel like you are in here for the first day ever. What's going on? AX plus BY equals C. We used it when we wanted to find the x and y intercept. That form was really handy for that. Lesson 4.2. I'm not giving it to you. X plus dy equals c. What's that form? Standard form. We have to start understanding right now today that every linear equation has more than one form it can be written in. One way it can be written is in standard form. The same exact equation with the same set of ordered pairs, with the same slope, with the same x and y intercepts, can be written in another form called the one we're going to start talking about today, slope-intercept form. So when we talk about standard form and slope-intercept form, we really have to have an understanding of it. It's just a different name for the same equation, just like the number 10 has how many names? Can you think of any other names for 10? How about 20 over 2? Is that another name for 10? Yeah, what's another name for 10, Nita?
The opposite of negative 10.
The opposite of negative 10. That's another name for 10. Dylan.
50 over 5.
50 over 5. How many other names do you think 10 has?
Infinite.
An infinite number of names. It's still the same value though. If I say to you, I'm going to give you the opposite of 10, I'm going to give you the opposite of negative $10, versus I say to you, I'm going to give you 50 divided by $5, am I still going to give you the same amount?
Yeah.
So you need to make that connection right now that when we talk about linear equations, they can have different names also. So standard form is one way to name it. Another way to name it is slope-intercept form. Anybody know from their SQ3Ring what is slope-intercept form? It's not AX plus BY equals C. That's standard form. Allison, what is it?
Y equals mx plus b.
Y equals mx plus b. Now notice, these are all little letters. Remember in standard form, it's capital A, little x plus capital B, little y equals capital C. And so each time we do these, we have to understand what are all of these variables actually representing. In standard form, that capital A is just representing the coefficient, what x is being multiplied by. It doesn't really have any other role. The capital B is representing the coefficient on y, what y is being multiplied by. Capital C is representing the constant in the problem. When it's in slope-intercept form, now notice there's no capital A or any capital B or capital C. So which of those four letters is representing the slope?
Y.
Kenzie? M. We already know from the slope formula, M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We already know that they called slope M. What do you suppose little b is representing then? The y-intercept. Yeah. B is the y-intercept. Well, that's pretty handy, because I don't know how many of you really studied the bottom of page 258. And at the bottom of page 258, they showed you a way to write an equation in slope-intercept form, given the slope and the y-intercept, and it was a way that was really ridiculously a lot of work. What did they do? Anybody know what they did at the bottom of page 258? They were given the slope, and you were given the y-intercept.
268.
268, I'm sorry, I was doing the wrong page number. No wonder I can't do that. On the bottom of page 268, I'm going to guess that you don't want to have to go through that much work every time. So what did they use? Which formula did they use? They used the slope formula. They said m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and then they substituted the slope in for the m, and the x and the y in for the y sub 2 or the y sub 1, and vice versa, you know. And then they had to finish solving it. They had to get the y by itself and the x over on the other side, and it took a whole bunch of work. Boy, I hope we don't have to work that hard. And we really don't. Because if this is slope-intercept form, and m represents the slope, and b represents the y-intercept, if we're given the slope and the y-intercept, we don't have to work very hard, do we? If we went through all that work, it'd get us to the same place. So let's get there a lot easier, because you guys are always looking for less work to show, aren't you? So what do you think could be the equation for number 1? Write the equation that describes the line in slope-intercept form. Anybody want to offer up what they think the equation could be for number 1? John, what do you think?
Y equals 5x plus negative 1.
Tell us what you did.
Well, you just set up the equation. If the slope is 5 and m equals 5, so you put the 5 in place of m. And if the y-intercept is negative 1, then you put the negative 1 in the place for where the y-intercept is.
If they say slope is 5, that's really the same as m, right? And if they say the y-intercept is negative 1, that's really our little b. So all we have to do is substitute that into our form, y equals mx plus b, and we have our equation. And we didn't have to work near as hard. One simple step instead of a half a page. Let's clean this up. How would this look in a multiple choice answer bank? Clean it up.
Y equals 5x minus 1.
Yeah, cleaned up, that we probably wouldn't leave it as plus a negative 1. It would be cleaned up y equals 5x minus 1. Okay, questions on it? Okay, who wants to offer up the equation for number 2? Aubrey?
Y equals negative 1/2 x plus 0.
Okay, so in other words, negative 1/2 is the m value. They said the y-intercept is 0, that's our b value. How would this one clean up? Kenzie?
Y equals negative 1x.
Y equals negative 1/2 x. Okay, we're going to stop for a moment. We're going to talk about these 2 lines. You're going to tell me something about these lines. You don't have to graph today, but you should be able to tell me something about the line or the equation without even having to graph it. You can't tell me everything, but you can tell me something. So number 1, tell me something about the line for y equals 5x minus 1. What's one thing,
It
Dylan?
would not go through the origin.
It would not go through the origin. Why not?
Because there's a negative 1 that is we're subtracting 1 from perfectly good equation. That
So
would go
it's
through
not
the
y equals kx form then, is it? It's not direct
variation.
variation. Okay, so it's not going to go through the origin. What else can you tell me? There's more. You guys can tell me at least a couple things more. What's another thing? Allison? Positive correlation or positive slope, which means what? What does that look like?
Rise
So, yeah,
from
Rise
left to
from
right.
Rise from left to right. Okay? Tell me something else. That negative 1 also tells you something else besides the fact that it's not direct variation. What else does that minus 1 tell you? That negative 1. It's the y-intercept. What does that tell us?
The 1 point is 0, negative 1.
Yeah. So we have an ordered pair of 0, negative 1. In other words, it's going to cross the
y-axis.
y-axis at
Negative 1.
negative 1. Yeah. So without even graphing this, there's some things we can say, if we did graph it, these are the things we could count on. We could count on it, it's not going to go through the origin. We can count on it that's going to rise from left to right. We can count on that it's going to cross the y-axis at -1. If those three things aren't happening, there's a problem. How about number 2 then? Y equals -1/2 x. Tell me something about that one. That's one thing about it. Kenzie, what's one?
It goes to the origin.
It goes to the origin, because this one is a
Direct variation.
direct variation. Tell me something else.
It's negative.
What's its negative mean? It's got a negative slope, which means
It's going down from left.
it better be going down from left to right. Well, if it's crossing through the origin, where's it crossing the y-axis? At 0. Oh, do you think we could start making some sort of an assumption about direct variation equations and their y-intercepts?
That they will always be 0.
That they will always be 0. Because if the graph has to cross through the origin, that means it's crossing the y-axis at 0.
And the x-axis.
And the x-axis is 0. So in reality, its x-intercept is also 0, isn't it? Okay, can you tell me anything else about that line? Okay, that's a good start. Okay, anybody want to give the equation for number 3? Equation for number 3. Dylan, what do you think it is?
Y equals x plus 4.
Want to agree?
I might be wrong, but that's my guess on it.
Because remember, when there's not a number in front of x, what's the invisible number that's really there?
1.
One.
So you put a 1 x.
Is the slope what?
No.
What's the slope?
0.
0. So what do we have to put there?
A 0.
We have to put a 0 in front of that x. That's not the same thing. 0x is not the same as 1x, is it? Can this be cleaned up?
Yes.
Okay, what would it be?
Y equals 4.
Okay. Because 0 times x is 0, and 0 plus 4 is 4. So, tell me something about this line.
Isn't it a vertical line?
Is it a vertical line? Slope of 0.
Isn't it just a point?
It's horizontal. It's actually a horizontal line, where every y value is what? Every point has a y value of 4. And every x value is not necessarily 0, but different. Right? Every x value is different, but every y value is the same. It's a horizontal line. Is it a direct variation then? No. Because is this going to cross to the origin? No. Where's it going to cross the y-axis at?
4.
4. So here it is. It's 4 units above the x-axis. It's a horizontal line. So the other thing we have to be able to do is once an equation is cleaned up, which is what they always do, they always clean them up, you have to be able to say, okay, well, it could have been this before they cleaned it up. So now we're going to practice doing the reverse. What if they give us the equation and we have to get the slope and the y-intercept from it? So, number 4. Is there something I could rename that as that might help us be able to determine it a little easier, Jay?
Instead of negative x, you could put negative 1x.
Okay, so instead of negative x, that's really the same as negative 1x, right? Which is kind of helpful because now we know what the m value is and we know what the b value is. What's our m value?
-1.
Negative 1. And our b value is 3. Okay, so m is negative 1 and b is 3. And that's going to be important that we can identify that. Okay, tell me something about this line.
It's a negative.
What does negative mean?
It's negative correlation, which means that it's going down from left to right.
It's a line that's falling from left to right. Direct variation? No. So is it going to cross to the origin? No. What else can you tell me?
It crosses the y-axis at 3.
It crosses the y-axis at 3. Okay, so those are things that we want to be able to identify even when we don't have to graph it. Okay, y equals -2. How could that be rewritten? What was that before it was cleaned up, in other words? Kenzie, what was it before it was cleaned up?
Y equals 0x plus -2.
Yeah, before it was cleaned up, it was that. So now that tells us the slope is what?
0.
0. And the y-intercept is
-2.
-2. Well, we're just going to actually go straight to, instead of having to write the words, we're going to write it as m equals 0, b equals -2. So let's do that and not have to even write out the words in our next one, number 6. Oh, by the way, tell me again, what kind of a line is this when y equals -2? Horizontal. Yeah, we gotta get used to that. When y is equal to a number, there are no x's, it's a horizontal line. Okay. Number 6, who wants to offer up what they think m is? And what b is? Nikki, what's m?
1/4.
Okay, the slope is 1/4. And what's our b?
-5.
-5. In other words, before it got cleaned up, it was what? 1/4 x.
It was 1/4 x plus -.
Yeah, it was 1/4 x plus a -5 before it got cleaned up. So the y-intercept is -5 now, +5, isn't it? Okay. Any questions on being able to write an equation given the slope and y-intercept? Find the slope and y-intercept given the equation to start with. Okay, those were pretty basic. Let's go to the back side now, where we're going to just do one other thing today. I've learned that in this particular lesson that's so important, if we cover too much stuff in one day, we get lost. So hopefully you're going to feel like we're taking it too slow. Cannot determine the slope and y-intercept directly when the equation of the line is in standard form. In other words, don't try this because students try to do it all the time. Tell me that the slope of that line is 8 and the y-intercept is 6. Because I don't think that's what we're going to find, are we? Can we get the slope and the y-intercept when it's in standard form? Can we just not do a thing to it and say, okay, well, x is being multiplied by 8, so that's the slope? No, you can't. What do we have to do?
You have to clean it up.
We got to get it in, what's that form called that we're,
The slope-intercept.
slope-intercept form. We need to get it solved for y, don't we? What does that mean?
Get y
We need to
itself.
Get y alone, yeah. Basically, it's like, get y alone. Let it be alone. It's got to be by itself on one side. So what would be our first move in this one? Subtract the 8x from both sides. We'll get the two y's by themselves first. Say, get out of here, x's. And now we have 2y equals,
6 minus 8x.
yeah, can we make that -2x? What do you think?
No.
No, why not?
Because they're not the same thing.
Yeah, 6 is not x's, it's just 6. And so we're going to have to leave it like this. Nita?
Could we put it as soon as y equals -8x plus 6?
Yeah, we could because we can change this to add the opposite, right? And then the 8x and the 6 can trade places because now we changed it to addition. So if we change it to add the opposite, then we can let the x's and the constant trade places. And now we'll move on to our last step, which is to do what? Divide by 2. And remember, when we multiply or divide, we have to do it to every piece of the equation. So we're going to have to divide the 2y by 2. We're not dividing by y, you guys. Some of you try to. The y wants to stay there. Don't divide by it. -8x has to be divided by 2. And 6 has to be divided by 2. All of them do. So what's our equation?
Y equals -4x plus 3.
Yeah. -4x plus 3. Well, the reason we went through all that is so we can get the slope and the y-intercept. So what's the slope of this line?
-4.
So m equals -4. And
b equals 3.
b equals 3. So tell me something about the behavior this line is going to do. What's it going to do on the graph? If I said to you, you had to graph this, this is what better happens.
It's gonna go down from left to
You
right.
better be falling from left to right, going down from left to right.
It's not gonna.
The y-axis at 3.
Better cross the y-axis at
Not
3.
It's not going through the origin.
And it's not going to go through the origin. It's not a direct variation, is it? Okay. Go ahead and do that last one on your own. Let's see how it works out for you. Okay. I'm going to try really hard not to pick on anybody here, but I better not hear calculators. Because you know what? People were not going to divide out the slope and get decimals because that's not going to be very friendly for graphing. You want fraction slopes. You want fraction slopes because then you have your rise and your run, and that's going to be very useful to us. So we don't need calculators any more than we did yesterday for the quiz, the test. We have y equals negative divided by a negative is a positive. 1x divided by 5 is
1/5.
1/5 x. Remember that x when it's upstairs can just come out like that? And then plus what?
2.
Plus positive 2 or negative 2?
Positive.
Positive 2. A negative divided by a negative is a positive. Okay. Is it in slope-intercept form? Okay. That means we're ready to identify the slope and the y-intercept. So what's the slope? 1/5. Y-intercept?
2.
Okay. What's this line doing?
Rising.
Rising from left to right. Going through the origin?
No.
No.
Going crossing the x-axis.
Crossing the y-axis at 2, right? We don't know where it's going to cross the x-axis right now, do we? Okay. We could pretty quickly figure it out if we went back to it in standard form, because we would put 0 in for y, and so where would it cross the x-axis at? What's the x-intercept? Negative 10. So we actually could pretty easily in this one, find out, but this is what we're worrying about today. Can we write an equation in slope-intercept form, and then can we identify the slope and the y-intercept properly from it? Or, if they give us the slope and the y-intercept, can we write the equation ourselves in slope-intercept form? Those are the things I want you to make sure that you understand so far in this lesson. Any questions?